We're going to do things where you're comparing to someone or something else. Okay, but we're going to do it today for probability, for P, and then the last Thursday we're going to do it for mu. So today it's going to be my percentage is higher than Robert's percentage, and then on Thursday it might be, you know, the product that I make lasts longer than the product you make. So think about this. Think about anything. See, when I'm watching TV, I really do hate commercials. That's one of the reasons I don't watch television, but I watch sports and I watch sports pro shows. I mean, my TV, I say jokingly, but the only channels I ever have on my TV is the NFL Network and ESPN, unless there's a game on. then I watch the game, but then you're stuck with commercials. But what are commercials for? Well, they're trying to convince you that that product is better than somebody else's, but particularly car commercials. No one ever just says, this is a great car. They always compare it to other cars in their class. Now, what do you mean? Well, for example, if you have an SUV, they don't compare it to sports cars, they compare it to other SUVs. Yes. If you've got a truck, they compare it to other trucks. But they'll always tell you that they're better in some category. They don't just say, our trucks are better than your trucks in every possible way. No, they'll say, our trucks are better than your trucks in towing capacity. They'll pick something that they're better than. They might not be better than anything else, but they'll pick the one thing that maybe they are better than. Can they just say that? Or is that something that's actually been proven? That's a tricky one. So whenever somebody makes a statement like that and you don't believe it, can you have tested? Yeah. So we're going to do a simple one today. We're going to test basically Roz versus Robert's free throw shooting skills. That seems like a reasonable thing to do. Okay. So the idea is, oops, you don't want all three bits. So Roz v. Rob. How's that? Yeah. This is going to be on you know, syndicated television later on today. We're going to have, you know, crowds are going to be lined up cheering, and they're going to be, you know, wearing their pictures of Roz on their shirts or the pictures of Robert. Now we're going to have a contest. The idea is you have to start with something. So it might be something as simple as we're trying to determine if one of you is better than the other, or if you're essentially the same. That's probably a good starting point. Or it could be no, Roz is leading the league every year in free throw shooting percentage, and Robert's the challenger, and he says, I think I'm better now. And we can compare it that way. That all things are fair. So probably if we know nothing, we'll say, we want to determine, is one better than the other? So what would we start by assuming? There's no difference. In other words, we'll assume your skills are equal, and we'll let the evidence say otherwise. Does that make sense? Mm-hmm. If we were flipping a coin and you flipped that coin 10 times and you got 6 tails, does that mean it's an unfair coin? Because you might flip it 10 more times and now you got 4 tails, and you flip it 10 times, you got 7 tails, and you flip it 10 times, you got 3 tails. Aren't all of these outcomes fairly common? And yeah, so that's not enough, is it, to just do it a few times and see one outcome? You'd probably want to do it a lot, first of all, to make sure. If I flip it 1,000 times and 60% of the time it landed tails, I'd say, no, that's totally unreasonable for a fair coin, which it is, by the way. Mathematically, that's not very likely. So if Roz goes out in the morning and shoots 100 free throws and makes 80, and then Roz goes out in the afternoon and shoots 100 free throws, is she going to make 80? No. Are you going to probably make near 80? Yeah, but it might be a little more, might be a little less. Maybe you're just tired. Maybe you were doing outside and it was really windy. I don't know. But do you all agree that there's no reason in the world to think that results are always going to be exactly the same every time? So the idea being, if every time you do it, it's reasonable to expect a different outcome, then if we start with the assumption that there's no difference between you, then if you guys both do it and your results are really close together, that kind of confirms there's really not much difference, is there? But if your results are really far apart, that would be the thing we'd be looking at. Okay, so what we do is we'd have Roz would take her number of shots, we'll call it N1, and your number of successes. Remember, X is also the count, our random variable counting. Then Rob would have his number of shots and his number of successes. Now, in a perfect world, we really like you to take the same number of shots. But maybe that's not realistic. Maybe you did it in the morning and you had a little more time and you shot 100 times, and you did it between classes and you only had the time to shoot 50. There's nothing wrong with that, because we're really looking at your percentages. But if we could have you do the same number of trials, that would be great. But that is not a requirement. So Roz's P hat, we'll call it P1, is of course X1 over N1. Rob's P hat is X2 over N2. And what we're trying to do is determine, is there really a difference between their actual P's? Remember, P hat is what we just saw. That's our evidence. That's what we witnessed. So if Roz makes 80 out of 100, does that mean her lifetime free throw shooting percentage is 80%? No, but it's certainly a good starting point. Remember, what you saw as a sample is always the best guess of what the population is going to be, but we know samples are not going to be perfect. Like an opinion poll. We took an opinion poll and 53% of Americans felt this way in our poll, 53% of the people that we polled. Does that mean 53% of all Americans? No, but it's a good starting point, because if we did it well, then the actual number shouldn't be much different. That's the assumption we always make, if we did it well. So Robert's actual lifetime free throw shooting percentage hopefully wouldn't be very far from this. Same thing with Roz, okay? So we always use this. The hat is what we actually witnessed, to say, what is her lifetime free throw shooting percentage? So I'll give you a simple example, okay? Shaquille O'Neal, you guys remember him? Mm-hmm. Shaq was one of the greatest players ever, but he was a horrific free throw shooter. I mean, his career percentage was somewhere around 50%. But let's suppose you turned on a Laker game and it's the fourth quarter and they just fouled Shaq and he goes to the line and he makes 2 free throws. He did that occasionally. That's all you ever watched him do, and you made 2 free throws. In your mind, you're saying, wow, this guy's good. Wouldn't that be your first reaction if you saw this guy make 2 free throws under pressure? You go, wow, this guy's a great free throw shooter. He makes all of his free throws. Yet in his career, which he played almost 20 years, he shot thousands and thousands and thousands and thousands of free throws, maybe tens of thousands of free throws. He only made about half of them. But could he go to the line and make 2 out of 2? Because the next time he went to the line, what might happen? He missed all that. But over the long run, he made about half of them. So you can't take a short little snippet and say that's what the population is. That's why you would want a sample to be really large. Again, it'd be like the coin flip. You're going to flip the coin once, one time only, and it landed tails. I guess that coin always lands tails, doesn't it? No, it doesn't work that way. Now, if I flip the coin 100 times and I got tails every time, yes, I'd be a little suspicious at that point. So we're going to do this. Now, I'm going to go over how we do our Z in this case, because it's a little different when there's 2 people. So what would our null alternative be? Well, if P1 is Roz's actual P1, not P1 half, but P1 is Roz's true lifetime free throw shooting percentage, and P2 is Rob's lifetime free throw shooting percentage, then our null hypothesis would be that P1 minus P2 is equal to 0. You do agree this is equivalent to just simply saying P1 equals P2. But the problem is I need to take a difference 0, because then I can take a difference of the measured guys. So we need to do it as a difference. P1 equals P2 is the same statement, but it doesn't give me a number. I need a number to actually calculate and compare. That's why we'll do a difference. So then what would the alternative be? Not equal 0, yeah. And the thing is, it would have to be really different for us to conclude that. Because the idea, once again, if Roz goes out in the morning and makes a certain percentage, and then she goes out in the afternoon or maybe the next day, we already know it's unlikely she's going to have exactly the same results. Again, we understand. So if we said, we say we're comparing Roz versus Roz. Roz's morning free throw shooting skill versus Roz's afternoon free throw shooting skill. Now, you'd say there shouldn't be a difference, but suppose there was. Your coffee hasn't kicked in enough in the morning. So Roz goes out in the morning and she's really awful. And then she goes out in the afternoon and she's incredible. And we see this happen over and over and over again. Oh, then we'd start saying, you know what, there's obviously a difference here. There's a huge measurable difference. Okay. When you're watching sports, and I like using sports because everything in sports really is based on probabilities. They use percentages, but percentages are just another way of probability. If I say the coin is 50% likely to do something, that means the probability is 0.5. We understand that those are interchangeable. In sports, don't they always give you situational things? For example, in football, when we talk about a quarterback, they talk about his fourth quarter numbers versus everything else, don't they? They'll say this guy in the fourth quarter does this, or you're watching the basketball game. You know, we're talking about Steph Curry in the fourth quarter, he does this, or in the last 2 minutes of a game, he makes this percentage. I mean, it's kind of silly, the detail, you know, the records and the statistics, those are called their statistics that they keep, but every situation, well, Roz in the fourth quarter of a close game, it's within 3 points, generally shoots this percentage. They're laughing, but they actually will report things like that, won't they? Constantly. In every sport, they'll give us details, you know, and baseball, they'll say this guy against left-handed pitchers in the 7th inning. Well, it's kind of silly, the detail, but they have the numbers there. So based on that, people make decisions in sports constantly. Constantly they make decisions in sports based on previous successes or failures in similar situations. So this is our null and our alternatives. That's easy. So with the magic Z and all that, we do the exact same thing, right? If I said I want this at the 1% level or the 5% level, you'd tell me. The problem now is, how do I calculate the Z's? Because before, what we did, when it was one person, remember the calculated Z, we said we had the claim, you know, Roz claims to be 80% and what we saw. So what we did was we said this is the measured minus what we're assuming from the null hypothesis. And then we said over what? PQ over N, and these are the null hypothesis. This is what we did when it was just one person. Okay, then so Roz claims to be 80%. We said, well, let's go out and have her shoot some free throws. As long as what she did versus what she says she can do, as long as that number is really small, that difference, then we'd say, oh yeah, it's probably reasonable. We're doing something slightly different now. Now we're comparing two people. This was the one person. So for the two people, it's slightly different because now we're saying, we're taking the differences. Oh, so we'd take P1 hat minus P2 hat minus P1 minus P2. I'll explain why we do it this way. And by the way, that's probably 0. It might not be 0. Now, the weird thing about variances add. This is a variance on the bottom. And then when I took its square root, that makes it a standard deviation. So what I do here is P1 Q1 over N1 plus P2 Q2 over N2. Each of their individuals. That's why I said if it's at all possible, what we'd like to do, now I'm going to show you there's an easier way we're going to do this. There's actually an easier version of this that I'm going to show you in just a second. This is kind of the generic thing, okay? We do two different variances. If at all possible, I said we'd love it if they could shoot the same number, Roz versus Rob, because it just makes the number crunching. If Rob only shoots 10 and Roz shoots 100, something doesn't feel right when I'm comparing my numbers, because one make or miss for you hugely changes the percentage, right? 7 out of 10 versus 8 out of 10, that's a big difference. Now, what we do in this case here, though, it's slightly different. This is the sort of the universal generic formula that always works. But there's a simpler version that people will use, and it's called a pooled probability. Pool. Now, when you hear pooling, what does that typically mean to you? In terms of money, kind of everybody throws it in together, don't they? So what we're going to do is, instead of the individuals, we're going to do for the P and the Q, instead of using the individual claimed numbers, which of course we'd be saying, we're trying to figure out if you're different or not, we're going to do a pooled probability. And this, it sounds a little confusing at first until we realize, oh, okay, this makes sense. If we're starting with the assumption that there's no difference, Remember, our null hypothesis is that there's no difference, which means right here, this number is a 0. And the reason that's true, it could be we're saying, we believe that Roz is exactly 10% better than Robert. And now you guys, when you go out there and you shoot your free throws, you are exactly 10% better than Robert. That's great. But then we'd be starting with the assumption that this difference was 0.1 because you're 10% better. Okay, that's a possible outcome. It's rare. It's usually going to be, are you equal or are you not equal? Not are you this much better? Does that make sense? But that's always a possibility. Our hypothesized difference is 0, which is the only one we're going to do, by the way, which means this number is always going to be 0. So what I witnessed versus what I hypothesized. But if this one's 0, then I don't really even need to write it down because it came from right here. Does that make sense? Now, if Roz shot free throws in the morning and then Roz went out and shot free throws in the afternoon, then how many free throws did she shoot altogether and how many did she make altogether? That would be your pooled probability. Oh, so pooled probability would be altogether how many free throws were shot and 1 plus x2. Altogether how many free throws were made? x1 plus x2. So the pooled probability, which we usually call, for lack, we're running out of symbols, we'll call P bar, is x1 plus x2 over n1 plus n2. The idea being, if there's truly no difference between your skills, then you shooting followed by Robert shooting is equivalent to you shooting followed by you shooting again. If we're assuming there's no difference in your skills, then it's almost like I could plug one of you into the other. But we also said if we do something twice, we're probably not going to see identical results. So what we do in this case here is if we're making the assumption that there's no difference between you, then we just take all the free throws you shot and made between you, and we use those numbers. So the formula we're actually going to use, it's a simpler formula. So it's a slightly simpler to use. So then we make this P hat Q hat. I should say P bar Q bar. Remember, Q is whatever's left. So if P is 0.8, Q is 0.2. We know that. And this is one of the reasons we really like it if you shot the same number of free throws. We'd love it if you did, but you don't have to. But it makes the calculation easier. Does everybody understand that part? It definitely makes the calculation easier because if you shot the same number of free throws, if that one and two are the same, then that means that that fraction and that fraction are identical. It's just easier to do on your calculator than you just double it. Does that make sense? So we're going to do the entire experiment here because this is actually how you compare probabilities. Now, I want you to think about it. Think about situations in your life that you've heard. And more often than not, when people think of situations, they think television commercials, because that's probably the most common way that you are flooded with statistics, is you're watching a commercial. Can anybody think of something where probabilities or percentages are compared in anything, any avenue of life? It could even be at school. What do you think? Can you think of anything? I mean, we're comparing free throw shooting skills right now, which is a kind of simple one. Could there be anything else?
Successful graduates. Successful graduates.
Okay, because we can measure that as a percentage.
Okay.
So how about we do something like this? Mesa College says this percentage of our students graduate and move on. Let's say graduate and transfer to a four-year school. I think we'd call that pretty successful.
Okay.
That, by the way, in case you're wondering, that is the #1 thing that we measure ourselves on as a community college, because our primary goal is to prepare you for the next institution. Do people finish here with a 2-year degree and move on and just do that? Yes, yes, we have a lot of programs, but most people go here with the intent of moving on. I have 3 Mesa College graduates so far, and I have one that's going to be at Mesa next year. So hopefully I'll have 4 in a couple of years. And then 3 of them have moved on. 2 of them have already graduated. 1 of them will graduate next year from 4-year school. That's what Mesa is. So we say this percentage of our people graduate. Now, what about Miramar City? They're in our district. We're all family. Can we say, we have a higher percentage than they do? Can we say that? I mean, in other words, is that something we could test?
Yes.
Yeah. So we'd say, okay, let's assume we don't. Let's assume we're the same. And then let's see if the evidence states that we're actually better. And if the evidence doesn't point out that we're clearly better, then we'd say, you know what, we're probably the same. And that's okay. But can you do that? Absolutely. So it could be something like, Junior says, I make 75% of all of my field goal attempts, no matter where I am on the field. Because he was out there kicking the ball the other day and he just couldn't miss. Okay. And Salvador says, well, I think I make a higher percentage than you. And we have some fun. So what would we start by assuming? That you don't, and let the evidence speak otherwise. We're talking about something where it's easy. This is what when we say things are binary, light switch, on, off. There's not a third option. So if you're kicking a field goal, if you're shooting a free throw, you made it, or you almost made it? No, you made it or you didn't. It's that simple. When it's because it's sometimes we use the term binomial. That means there's only two possible outcomes: success, failure. And failure doesn't mean you failed. Success is whatever it is I'm counting occurred. See, I could be counting how many you miss. And so a success would be you missed it if I'm just counting misses. So does that help? So the idea being, when I'm comparing things that are nothing more than a probability or percentage, it makes it fairly simple. And we're generally comparing, usually it's equal versus not equal, but it could be equal versus better than or less than and all that. So now let's set up the original problem. So it's, yeah, it's also, I'm recording it. All righty, so now it's going down. I got a hold of ESPN. They're going to send out a film crew. So now it's the epic event we've all been waiting for. Rosalind versus Robert. R&R, and the epic free throw shooting battle. So we want to determine, let's actually state in words what's going on. If there is a difference in free throw shooting, skill between Robert and Rosalind and Robert. Come back to all this stuff in a minute. And Robert. Okay. So let's say we want to do a test. We'll keep it simple. This is probably not life and death. This is not approving a wonder drug, for cancer treatment. This is who's a better free throw shooter. So we'll use the alpha equal 0.5. You generally only use 0.5 or 0.1. And I mentioned 0.1 if it's something that's really, it's life and death. It's an approval of a wonder drug or something. We want to be even more strict. Most of the time it's 0.5 because this isn't absolute life and death kind of stuff, right? So at the 0.5 level of significance, test their skills. All right. So we agreed before that the null hypothesis would be that there is no difference. So the null hypothesis is now rather than say P1 and P2. Actually, let's do. We'll say Roz was 1, Robert was 2, because I need to make sure when I'm putting numbers down, which one it applies to. Okay. So Roz, where you're going to be number 1, Robert, you're going to be number 2. So the true lifetime free throw shooting skill, there's no difference. That means the difference is 0. My alternative hypothesis is that no, there is a measurable difference, but we don't know which way it goes. We're not saying, well, either Robert's the same or he's better. Robert's the same or he's worse. No, we're saying Robert's the same or he's not the same, because we don't know. We truly don't know. Okay? Since this is going to be a two-tailed test, isn't it? What does that mean? Again, that means I will reject in either extreme. And since it's at the 0.5 level, that means each tail has exactly 2.5%. So what is the Z that corresponds with an 0.25? Good, you guys, you said, I know that one. That was the one that we use the most often. Okay, there's only 4 numbers, and I don't need you to memorize them, but I need you to have them handy at all times. Because remember, 1 tail versus 2 tail, it's not the same thing. Okay, so this is a 2-tail test, that's why we cut it in half. So what does this mean? This means we will reject the null hypothesis if we are in either extreme. So what? If the measured Z is bigger than 196 or what? Perfect. That's exactly it. Or less than the negative.
I know I was late to come into this. The zeros, like equal to 0, not equal to 0, so originally using 0.
Yeah, because if we're trying to conclude, is there a difference or no? That's the same as saying P1 equals P2.
So either it's the exact same.
Or they're not. They're either equal or they're not. But the reason we write it as a difference, because we actually need a number. We need a number to measure. Oh, so when we're actually measuring their skills, we have to measure, is there a difference between them or not? So if we assume there's no difference, then the difference is 0. That's the same as saying they're the same. But the problem is same versus not the same. What's the number I'm going to use when they're, I have to take a difference to determine that. All right, so with this, we're going to go now. Remember, this is we've designed the experiment. Now we actually have to have them go on free throws. So they go out and shoot free throws. So here's the data. So Roz goes out, and as always, Roz shoots 100 free throws, and Roz is going to make 80. And like I said before, Robert didn't have quite enough time to shoot 100. So maybe Rob shoots 50. And let's say Rob makes 37. He was getting warmed up. He would have made a lot more. Okay, that could be a contributor. Yeah. All right. This is what we witnessed. Now, really, the question is, are those numbers so extremely different, or are they close enough together? We don't know. We actually have to do a calculation. Okay, you with me on this? So this is what we view. So let's calculate. So what is our P1 measured? Well, that would be 80 over 100. And by the way, if that's a terminating decimal, then absolutely you can report a terminating decimal. Okay, there's nothing wrong with that. So 0.80, and then Robert's measured was 37 over 50, which is 0.74. I mean, not a huge difference, but maybe it's enough of a difference. Again, we don't know. Again, the idea being, if Roz goes out and makes 80 out of 100, and then later on in the day, Roz shoots 50, she might make 37 out of 50. So the whole idea of pooling is, if we're trying to determine if there's a difference, and we start by assuming there's no difference, we're kind of assuming it's like the same person did all of the shooting and saying, is that reasonable that they would have had this much of a difference? So now let's calculate our pooled probability. The pooled probability, which I call P bar, just says, okay, how many free throws were shot altogether? 100 plus 50.
150.
Right out. How many free throws were made altogether? 80 plus 37. So that would be what? 117 over 150. Again, it's as if the same person did all the free throw shooting, if I'm thinking of pooling. I said for convenience sake, it would be awesome in reality if we could have the same sample size for each one, but that's not a requirement. Everybody okay with that? That's not a requirement. It just is convenient. When you're going out and you're doing your opinion poll, you get to choose how many people you're going to ask. So in a situation like this where you're shooting the free throws, maybe Robert says, no, I want to shoot 100 because Roz shot 100. It's actually easier to compare that way, and you're right. But that might not be possible. Okay. So does this convert nicely to a decimal? If it doesn't, then we just use that number. 0.78. Okay, so it's a terminating decimal. That's nice. It makes my calculation a little bit easier. Now, there's no conclusion yet. We set up the experiment. We set up our hypothesis. That's always in real life. In real life, that's always done before the data is collected. Because we talked about this before. You don't collect the data and then decide on your hypothesis.
Set it up first.
Let's spend millions and millions of dollars collecting data without any purpose. Now we'll form a conclusion and a hypothesis after we've collected all this data. I'm pretty sure nothing in the real world would work that way. Who's going to spend lots of money collecting data without any point? No. I have an idea. I think this is what's going to happen. So now I'm going to collect the data to see if it supports my idea. That's what you do in real life. So the statement was made, whether it's by Ross or who knows, but somebody was saying, hey, we want to know, is there a difference in the free throw shooting skill? So let's start by assuming there isn't, set up our whole thing. Now we're going to have you guys go out and shoot free throws. We're going to count, we're going to measure. This was really complicated, right? No, this was really easy. You just went out and made free throws. We counted them. Now we've got everything we need to do the final calculation for the Z. So now let's calculate the Z. Of course, I must use a different pen. So what is Z star? Okay. The measured difference, zero. Ooh, this is a bad pen. And my black pen's dying on me here. 0.80 minus 0.74 minus the hypothesized difference, which of course was 0. It seems redundant, but I said there is a situation out there where we might hypothesize a difference other than. Okay. You said, what do you mean? It might be something like this. Roz, from her lifetime free throw shooting, says, you know what? I usually am way better in the afternoon than I am in the morning. In fact, I think I'm 10% better or 20% better. Well, that would mean that our hypothesized difference isn't 0 now. It would be another number. For all practical purposes, you're almost always going to be 0 here. So it seems redundant, but again, that 0 came from that hypothesized difference. Now, what goes here? Ooh. Here, the N1 and the N2 go in the denominators for the formula, but the numerators are going to be the same. They're going to be P bar, Q bar. Well, P bar is 0.78. If P bar is 0.78, then what's Q bar? What's left from 1? If you're making 78%, then how many are you missing? 22%. Yeah, this is not rocket science, right? Those have to add up to 1. 0.22, 0.22. Now, I truly have no idea what the results are going to look like. We're going to get out our calculators. We're going to calculate them. Lots of parentheses. Now, this one's going to be a little bit taxing. There are some tricks that you can do, by the way. There are some tricks that you can do. Okay, but I definitely need lots of parentheses. And so, do you need a calculator? Yeah. Okay, so clearly the numerator, you're going to do your parentheses on the numerator and close it, or you can hit equals. Either one's the same thing. Finish your numerator, and it should say 0.06. Now, you're going to go, I'm going to put numerator divided by, and then the big square root symbol. Now, I only need a parenthesis. Remember, we write parentheses here so we can read it. These parentheses are not required on entry. So just go number times number divided by number. That's all you got to do. Number times number divided by number plus number times number divided by number. Oh, but number divided by plus number divided by, close your parentheses. The reason you're closing them is you're telling your calculator that I want all of this under the square root. Now, this might take us a couple of tries. That's all right. The thing is when you write down all of the numbers correctly and everything you have correctly, this should be the least taxing part, entering it on your calculator. But because there's so many numbers, it's really easy to have a Now you might, can anybody tell me why we often get error? That's why I found out I should say error.
No, but I done that.
But does anybody ever get error when you're doing stuff like this? Yeah, it's usually because you had an open parenthesis, but you forgot to close it. Or you never had the open, but then you closed it. You need both. Okay, hold your number for a minute. Let's see if we all agree then. So again, so I go 0.78 times 0.22 divided by 50 plus 0.78 times 0.22 divided by 100. Close my parentheses. What do you have on your screen?
0.836.
Does anybody else get that? I got that too. So we got to do it a couple times, make sure we get it.
I didn't use them at all. So.
Oh, you under the square root, you're going to have to, because you got to tell your calculator what you have. So when you hit the square root on the bottom, then you're just going to go 0.78 times 0.22 divided by 100. You don't need any parentheses. Plus, then do the second one. Complete that. Now, when you close it, you put all of it in the square root. Yeah. So 0.836. Does it better see that one? Off. Yes or no? Not yet. Well, that's your number. You haven't done divided by. You got to do the whole denominator.
So you said put it out there like this. For the parentheses.
So you don't need parentheses around the outside. No, it's square root. But your calculator's already putting stuff on the inside, so you don't need that. Yeah, that first parentheses isn't necessary. Yes.
So I'm doing this slowly.
That's right.
So I did the top.
Okay, so divided by
Divided by.
square root.
Okay.
Okay, now put your open parentheses.
Oh, now put it, okay.
Because now we're gonna put all of that stuff on the bottom, just from left to right. You don't need any more parentheses until you're done. So 22 and divided by 100
Okay.
plus. Now you do the second fraction.
In parentheses?
Nope.
Okay.
No, all, because you're telling your calculator.
Not yet, not yet.
Not yet. So with all of this under the square root times 0.22 divided by 50. Now I'm done. So close parentheses.
On the bottom or the whole?
Just close parentheses now. Now hit equals.
Oh. Okay.
So parentheses are actually our friend. People hate them. No, parentheses means I'm going to get the right answer. So we get approximately 0.836. Now, let me go back to my picture. Our result is about here. Are we anywhere close to the shark infested lava?
No.
Not even close. No, not even close. Now, this is where, okay, you're done with the experiment. Remember, you can have a press conference later, because this was all broadcast on ESPN. You got Dickie V and all these basketball folks, and they're all going to say stuff. But like, okay, no opinions. This is not about opinion. This, what did the number say? You're right. You know, if Dickie V gets involved, you know, when Ross is done, she was awesome, baby. The whole 9 yards. You guys, that's Dickie. Everybody knows Dickie V, right? He's a one-trick pony. That's all he ever says. He's awesome, baby. Okay, so do we reject or do we fail to reject? We fail to reject. So we fail to reject the null hypothesis. So what is the truth? They have to have a conclusion. Remember, you reject or you fail to reject. So what's the truth? When you reject the null, the alternative is the truth. So you state that in words. When you fail to reject the null, you can say the null is the truth. Or you can just say the safe answer is always there's not enough evidence. Their free throw shooting skill was definitely not identical, but that's a pretty wimpy Z. It's not, you're not close to rejecting. So there's two things you could say. You could say, you know, it's reasonable that there's no difference in their skills. Or you can be safer and just say there's not enough evidence to conclude there's any difference in their skills. I'd probably opt for that one. Fail to reject the null hypothesis. There's not enough evidence to conclude there is a difference. You guys happy with that answer? What if my Z what if my calculated z was really close to 0? 0 would mean they're identical, right? What if my calculated z was really close to 0? Would you say that's pretty convincing evidence that there's no difference? Yeah. What if my calculated z is really close to one of these numbers, but still not in the shark-infested lava? You wouldn't say they're the same, but you'd just say there's not enough evidence to say they're different. So this not enough evidence is probably the safest conclusion. Yeah, right.
I said going back, so I'm with you all the way. Okay, you got 0.836. Then on your graph,
I'm showing that's about right here.
that's about right there. Okay, and so
We're not really close to rejecting. Rejecting, we're in the tails only, right? We had to be bigger than.
There's not a big difference.
There's not a huge difference.
Okay.
There is an obvious difference, but it's not a big difference.
It's not a big difference.
So really, it comes down to this.
So not enough evidence.
There's clearly not enough evidence to say you're different.
Okay.
You would have had to been in the tails.
I see.
But would you say you're the same? You go, probably safer to say not enough evidence. Now, here's what I said a moment ago. What if this calculated number was not 0.8? What if it was like 0.1 or 0.2? What if your calculation was really close to 0? Remember, if you shot in the morning and then you shot later in the day, we already agreed that you're not going to have identical results, but your results are probably going to be fairly close. What if this is you? You're going, you know what? Those results are so close together, you might as well say I'm the same. These results, I don't think it's that close that you could say, no, our conclusion is they're the same, but you definitely said they're not different. You know, but is everybody okay with that? That's whenever you fail to reject the null, the not enough evidence conclusion is always correct. It's always safe, but there's sometimes you fail to reject the null, but the evidence is screaming at you. You know, let's say, what if we made that, Robert, what if you'd warmed up a little longer and you made 39? Our Z value would have been tiny, tiny, tiny. And you'd say, you know what, my God, they were almost identical. In other words, your conclusion might be, okay, failed to reject the null. I think they are the same. That's a totally okay conclusion. Does that make sense? Yeah. So this is an example of how we compare it. So what we did last week was we took one person or one thing and then compared it against a null hypothesis, right? It was just Roz saying, hey, is Roz this good? But in real life, more often than not, you're compared to other things. So we'll use colleges as an example. This is one I'm going to use next day anyway. And I like Roz's idea of transfer. So let's actually set up that problem. And we're trying to determine, let's say, within our district. Okay. So new problem. All right, so I'm just making up the numbers. I don't know if these are accurate or not. I would guess they're probably going to be not too far off because I do have some insight. But let's say we're talking about transferability between Mesa and, let's say, City College. All right, so at Mesa, we believe we have a higher transfer rate than City College. Okay. Okay. Now, I don't have, maybe none of us have access to the numbers, but we want to be able to brag and advertise and say this. So what we really need to do is then take a look at the numbers later. Now, be careful on this one. Okay, both schools have been around for a long time. We've been around since 1964. So what if we only took last semester's transfer rates? Would that be a good way of doing it? Or should we do it over a long period of time?
Long period of time.
Probably a long period of time. But maybe I just got some, I got some sample data, from last semester, or maybe from last year, or for the last 3 years, or something to that effect. But I think we have a higher transfer rate. And I actually think that's true. But wouldn't we have to prove it? Well, we have to prove it. You can't just say it. That's I'm better than you. Okay, I believe it. No, I think you would say, show me. You know, this is real life. Statistics, you don't just get to say things and walk away and not have to prove it, right? I mean, you kind of have to back up when you say something. So let's say we want to test at the, let's use O1 this time. Level of significance. Okay. Now, what it is we're going to do is we're going to find out how many students were there and then how many students transferred, let's say. We took a sample. Now, the thing is maybe this data isn't readily available. Maybe we actually have to sample people. So it might be something like this. Okay, somebody comes to our class, and by the way, this is the right time of year to do it in May, because anybody who's transferring in the fall typically has heard by now whether they've been accepted or not. You see, you might have every intention to transfer, but if nobody's accepted you yet, you're not counted as a transfer student for the fall, are you? Oh, but let's say Robert applied to 5 different schools and they all accepted him. He just has to pick out which one he's going to go to, but you are now considered a transfer student. Because you have to be accepted somewhere. You can't just say, I'm going to leave Mesa and go somewhere else. That's not a transfer student. You actually have to have a destination. You have to have been accepted there. Does that make sense? And in May, generally that's about the end of the time. A lot of private schools wait longer. Yeah, I have students who are still waiting to hear. Some of my desktop students are still waiting. They haven't heard yet. It's kind of, kind of iffy. So we go around and we collect data. Okay, so first of all, we need our null and our help to an alternative hypothesis. So let's call it probability Mesa and probability city. I'll use an M and a C as a subscript. Why didn't I do that before? Because Rob and Roz both start with an R, and that really would not work very well. Probability Roz versus, then I'll just use the first 2 letters, right? Probability of RO versus, no, that wouldn't work either. That's why I used 1 and 2. But now I'm doing city versus Mesa. So it's going to be something about probability Mesa minus probability city, probability Mesa minus probability city. We think we're better. That's an inequality. So what do we start by assuming? We're not better. What is not better? Not better is same or
not the same.
Not better is same or worse.
Oh.
If I say I'm better than you and you say no, you're not, that doesn't mean it equals the other. What if you're actually better than me? Oh, so remember, the null always has to have the equal. I'm saying I believe Mesa is better, and you're saying you got to prove it. So the null is, well, what's left? Less than or equal. So now we let the evidence show us. By the way, we're probably not going to be less than, but the evidence has got to be strong before we say before we can actually say we're greater. What does our picture look like? We will reject where? Left or right tails?
Greater. Right tail.
Again, I'm a big fan of the picture. Okay. So it's a 1-tailed test. So I want the Z of 0.01. What is the Z that has exactly 1% in the tail?
2.326.
2.326. So we will reject the null hypothesis if our measured value of Z exceeds that number. Agree? So again, we're now doing a 1-tail test. We started by doing a 2-tail test. This example will do a 1-tail test because this is probably just as common. So basically it's Mesa is better or they're not. We're not, before it was Roz and Robert are the same or they're not. That's not the same thing, is it? That was an equal versus not equal. This is we're better or we're not better. That's better, that's not better. Not better means we could actually be worse. We go all this time believing, that we're the best, and then we find out, oh my God, maybe they were better than us all along. That's a possible outcome. So we go out and we collect the data. Now, the data is basically, we ask students, are you transferring or are you not transferring? So it's a simple, right? It's a yes and no. No, there's no maybes here. Okay, so let's say we go out and collect the evidence, all right? So the number at Mesa we asked, let's let me just pick a random value. Let's say we asked 137, and the number of people in that group that were transferring were 58. By the way, not everybody's transferring. A lot of people are still here. And then we went out and we went to City College and we asked 85 people, and the number of the City College people that were transferring, let's say, was 31. Okay.
137, that's how many you sample? And
Yeah, that's my sample size, and that's how many yeses.
okay, got it.
Okay, you with me so far? So, what is my measured probability for Mesa? It would be 58 over 137. What is my measured probability for city? It would be 31 over 85. Now, those are not going to be terminating decimals, so we're going to leave them as fractions throughout the problem. Remember, you only convert it to a decimal if it's a terminating decimal. If something was 1/3, you don't write 0.33 in your calculator because that's not equal. You just leave it as 1/3. Okay, so far so good. These are our measured values. So the question is, are they different enough to make a conclusion, or are they not different enough? We don't know. We're going to have to pull out our calculators in a little while. Now, the only other thing we still need to do before we calculate the Z is the pooled probability. So the pooled probability, how many successes do I have? 58 plus 31. Sample sizes, 137 plus 85. This is not complicated. Okay, and what does that come out to be exactly?
89 over 222.
89 over 222, and again, that is not a terminating decimal, so we'll leave that. Now, that's p hat, or excuse me, that's p bar. What does that make q bar? I need my calculator. Before when I said, you know, if p bar was 0.9, then q bar is 0.1. That doesn't require any calculator rocket science. Agreed? But now I have an icky fraction. Oh, so what's if I take 1 minus this? What will that be? It'll be something over 222. Does everybody see that? 133? You just did 1 minus that.
What do we do now?
Well, I need my Q, but I don't want to do that in my head. So I'm gonna use my calculator. So 1 minus that. But use your fraction key.
1 minus 89 over 222.
Yeah. Now, but use your fraction key.
Okay.
You guys know how to use your fraction key? That's the yeah.
I don't have that.
Yeah.
No, I don't.
So you're gonna go 1 minus 89 over, what was it,
Oh, got
222?
it.
And that's 132.
That's a fraction key?
Yeah. By the way, the fraction key is probably my favorite key on the calculator because it saves me a lot of pain and suffering. Do I need the Q? Do I need the Q? Yeah, because in my formula I have P bar, Q bar. If I told you P bar as a decimal, then you could probably do Q bar in your head. You know, if P bar is 0.6, then Q bar is 0.4. That doesn't require a lot of thinking. But I left it as a fraction. Now I can do that, but I might make a mistake. So I'd rather use my calculator just to be sure. And by the way, what do I know is an absolute? If I have these two together, they're gonna add to 1. If they don't, I'm in trouble. P and Q kind of have to add to 1. That's what they mean. So now let's do our Z star. Another black pen biting the dust. Jeez, please. I'm gonna reload some of these bad boys. All right. So our Z star is the measured difference, which would be 58 over 137 minus 31 over 85, minus the hypothesized difference. And we start with the 0. That's one of the reasons we write as the difference. I have to have a number, and it's 0. Pretty much. It's almost always 0. Okay. over. Now, what am I gonna use? 89 over 222 times 133 over 222 over 137. Then the same quantity, 89 over 222 times 133 over 222 over, what's the other one? 85. Yikes, it's a lot of numbers here. But once again, believe it or not, when I do the square root and I do my open parentheses, I can literally go this divided by this times this divided by this divided by this plus this. I don't need parentheses for any more of the calculation until I get done. I just enter them. And by the way, you can use your fraction key, but you don't need to for the simple reason in the end, you want the decimal value. Even if your answer was a fraction, you want a decimal value because that's what we're comparing it to. So what you might want to do is go ahead and complete the numerator first. I like what Roz does. Roz just does the numerator equals and then divide it by. Or you can do the numerator in parentheses. Both are correct. Tell me when you got a number. This is a long one. This is in terms of the calculation. Oh, well, actually, I got a slightly different one. Actually, I got the first part. And go ahead and scroll across. Oh, it's not 135, it's 133. No, Q has, or Q bar is 133. It's just a scribble. I have a scribbly 3 there, that's true. But yeah, you see, your answer is very close, but it was 133.
I'm getting ready to divide by 137.
Okay.
Divide.
Oh, but that's all going to be under the square root.
Oh,
Yeah.
I gotta go slower. Okay.
But it's not going to be way different. It's going to be similar. Oh, that is way different.
The square root.
But it was using the previous answer too, though. You had done the calculation already. So you might have to start that one over again. Well, apparently get 222 times 133 over 222 over 137 plus 222 times 133 over 222 over 85 plus parentheses. See what it's doing? It's using your previous result. So each time you go answer, it's not using your original answer. It's using.
Oh.
Yeah, that's the problem. So re-enter. Oh, you don't have to erase it. Just re-enter that where it says answer.
Re-enter what?
Your numerator. You don't have to re-enter the denominator. If you can delete the answer part.
That's so much work.
Well, but your calculator will allow you to do that. But every time you hit, it's updating your answer from the previous answer. So that's what it's using as an answer each time. And does anybody have a number yet?
No, I'm gonna have to read it. I'm not sure.
I'm going slow.
Go slow.
This is what you said. I'm sorry.
This is just like the last problem, except we're entering fractions.
That's why I forgot to do last.
Okay, so open parentheses.
Oh, okay, now we did. Okay.
And then
89.
everything, 89 over 222 times 133 over 222.
Okay.
Yeah, just everything.
Plug it in.
Does anybody got a number yet? No, that's easy. I think that's right. Yeah, way up. It's a little off. First of all, at no point do you want to calculate a decimal in the answer. That's an absolute guarantee that it will be off. Yeah, you only hit The only decimal you're ever gonna do is when this is all done equals whatever decimal that is. Because you've calculated a decimal and rounded it, calculated a decimal, rounded it, calculated a decimal, which guarantees you, whatever your last decimal would be, impossible to be great, but actually almost all of them are good.
Oh, okay.
Whoever told you that never enter a rounded off number in your calculation, that's an absolute number, because that guarantees that you're gonna be off. No, enter just 89 divided by 222. Just do that. And what you find is that when you get done, you hit equals, that will be great.
Is this
But you're calculating and entering the calculation, so you're actually doing more work. Because you're calculating twice. What do you got? Yeah, you were really close to that first time. But the reason it wasn't equal is because your fractions were slightly off. That's why I said it was really close. All right, I believe, because Destiny got it, I believe the number is in the range of 866. Does anybody else get that? I know, I think Salvador, you got that? I got that. You're not doing this by hand, but you could use a calculator, but you got to trust that you're entering the buttons correctly. This is the longest calculation we've done. And part of the reason this one is longer than the other is those fractions, 58 over 137, 31 over 85, they're not terminating decimals. So I don't want to calculate a decimal and re-enter that. Oh.
That's why I'm.
Start it, and then.
Got it. Okay.
Because the reason for the parentheses is your calculator doesn't know what's supposed to be in the square root. That's what the parentheses are doing. What is the X? Oh, okay, so are you able to finish that one?
What I'm doing is the 135.
Okay, so finish that one. We still gotta get one more fraction, looks like.
I want to.
Go to node and then go to comp
Oh,
one, right? And then
I've never seen that before. Okay, so maybe,
I did the bottom.
that is crazy.
There's not enough.
Let's tell you.
to do the whole problem.
Your calculator won't let you enter another number. Well, there is one thing you can do. You can actually factor the numerator. Okay, wow, that is unusual. Now, Robert's calculator would not let him finish. Did your calculator let you finish?
Yeah.
Yeah,
But
What?
not in the same sheet. It just has,
so what did you do?
I did the numerator first and the.
Okay, so he had the same problem. He just went ahead and totaled his numerator first, then divided by.
And then like this. I did the input answer.
Okay, so what he did was he totaled his numerator, it equals, and then answer divided by that, and it let him do it. This is crazy. Are you having any problem?
I'm right here. And then, oops, no. No, I'm not having a problem.
1.4 is too big though.
And then just hit the arrow.
Yeah. Guys, apparently some of your calculators, because the ones that have all the displays are limiting you on how many things you can put in. So it may be wise to just go ahead and total that first, then do divided by square root, because I have a cheap calculator and it lets me put in as many numbers as I want. But their fancy display calculators apparently have an upper limit. So if you hit equals and then divided by, it'll say answer divided by. But the bottom part's still got to be square root. You start your parentheses right here. You close your parentheses right here. Okay. And your final answer should look like this. That's how you know. Because I've got more than one of you have got the same answer. Again, you guys you're setting it up correctly, but you want to be able to get the right thing on the calculator. That'd be really handy dandy. Having any success? See, this calculator is actually more friendly because it's not going to limit how many things you can do. The fancier the calculator, this seems like the more limitations. All right, so you've got, okay, so now divided by. So now we'll do the whole denominator, divided by the square root.
Oh, but I didn't do that.
Well, no, you've got the numerator.
Oh, I did.
We're gonna do it differently and see if it's. So divide by square root.
Okay.
Open parentheses.
All right.
Now, just simply that times that, divide by that, times that, times that, divide by that, close parentheses. Just go slow in the entering.
And then hit answer.
This is quiz 19. I
And then
just
just do
don't
the
know.
homework.
Oh, this one. Yeah, they're all good. All right, we got anything left here?
Almost there.
Again, you love calculators because no human being would want to do that by hand. Almost. It's slightly off. This same thing happened to Destiny. 135, it's 130.
I told you.
Was it
Oh,
three?
three. I see.
You just messaged me?
You're, by the way, I believe it or not, you did it right. You just said it wrong.
I'm right here.
Okay,
Now divide by.
divide by 137. Get out of that fraction. Okay, now divided by 137. Now that's just one more thing to think about, and then plus sign. And you're gonna have exactly the same thing here, but as soon as you hit the divided by 85, then you
Parentheses. Okay, let's see.
you don't need any parentheses now, not yet.
Can you take a break with
Yeah, let's
Times.
133,
Over 222.
and then get out of that one, divided by 85,
85.
and now close your parentheses. And hit equals.
Woo!
And there you go.
Yes.
All right.
Yes.
Is there a quiz
Okay.
22?
That would be, well, actually, yeah. There is a quiz 22.
This is not on the Canvas bit. So I didn't know.
Actually, I'm pretty sure.
You have the test.
Yeah, we can practice that for, but quiz 22 isn't on Canvas yet.
Oh, here.
It stops at quiz 21. I know, 'cause I look every single day.
Yeah.
Hold the phone. What did you just turn in just now?
Quiz 20.
Or-
The quiz 21 will be next time. Between quiz 22, it's on the topic we're doing today.
Oh, darn. Hold the wait a minute, am I looking at the right thing? I could have sworn I posted 2 quizzes over the weekend. What else? Did you guys see the practice test?
Yeah,
Yeah.
practice test on there.
Oh, that took so long to write.
Quiz 22.
My computer is really old.
Or the upper one.
The problem is I have equation editor. I've been using that for a couple generations. I bought a new computer about a year and a half ago from Costco, and it was the newest version of Windows, and Windows no longer supports equation editor, which means that I've got 30 plus years of, I have thousands and thousands of documents that I've written, math stuff. There's no new version. So it literally would mean I have to rewrite everything. I can't carry it over. I can't edit it on the, so I never hooked up the new computer. So I have my old computer, but it's old and it freezes a lot. And I was doing restarts every 15 minutes.
Wow.
I mean, it's bad, but I have too much stuff on there and I have no way to do the math writing with anything new because they don't exist. And it really, it set me back. And so writing the practice test key took all day yesterday because of having to restart multiple times. Now, no one else, you're never going to have a class as long as you live in math where they give you a practice test and give you a key. Nobody does that. I do that because I like people to be prepared. You know, to me, it's a no-brainer, but a lot of people don't do that.
So me and my family were bored, so we're looking at the $1 million homes in our neighborhood.
And when you ran into my house?
That one's 3.3.
Wait, hold it, go back. What's it on? So it's on an island.
It doesn't Escondido. All these houses are in
beautiful.
Esco, but I found a $12 million house
In Escondido?
in Escondido. This thing is ginormous.
$12 million house in
It's a
Escondido.
$12 million house. It's freaking insane.
Wow, that's where my wife works.
Like this house could be, I don't know how to start. I just feel it. This one's 4.2.
Yesterday, I had the urge
Isn't
That is
cute?
well lit. I like that.
I know, I thought it was really pretty, but you don't know. These houses.
Did you guys do your prom?
Not next week.
Oh, I thought it was last weekend.
Oh, next Saturday. Oh my God, you're still going to prom? I did that 4 years ago. I got my dress. Wow. Did you get it tailored? Not yet. Did I pick the school? Oh, you did? Yeah. So that's crazy. This one's in Rancho Santa Fe. It's 98 million. 15,000 square feet.
98 million.
98 million. Oh my God, look at it.
You're hanging out with the wrong people.
Look at that. Where the hell? I need to be friend. Oh my God. Look at it.
That's
It's a freaking campground.
That's kind of
Look at
silly.
that.
It's a little overkill, don't you think?
Right?
I don't know, I wouldn't know what to do with that. If I wouldn't know.
All right, here's what I would like to do. Since I apparently, I can't believe I only loaded quiz 21 and not quiz 22.
Just upload it right now.
I can't, it's on my home computer, not on this computer.
You can't do it on the school computer?
I can't access my home computer from the school computer. No, it's a good thing that I can't access my home computer from somebody else's computer, because otherwise you could get to my home computer from. So here's what we're going to do then instead. We're going to look at some of this.
Yeah, I think it's in a real estate area. Just start selling houses in Rancho Santa Fe.
All right.
Oh my God.
So here's what I would like to do. I can never get, there we go. To make the best use of our time.
Oh, the recording or the,
I haven't stopped recording yet.
okay.
To make the best use of our time, I would like us to actually work on the redundant practice test.
Let's do
I
it.
think so.
Just again, so everybody, sometimes we get lost in the shuffle because we're so intense and so busy. Everything on the test we've already covered. That was through last week. We're going to review the usual Zoom review on Friday, and our exam is next week on Tuesday, and that is our last exam.
Next Tuesday? It's on the 10th?
You have a schedule, it hasn't changed.
On the 10th, but why the hell do classes go until the 27th?
No, not the
Or the
10th.
26th? No,
What?
our quiz, our exam. Exactly. Then we have a final. You said that's the last exam.
Yeah, this is exam 4.
Doesn't make the final. He doesn't.
Oh.
So there's 2 more exams.
Well, the final exam is,
I know what you're saying.
that's the end of the semester.
Right, but you
Yeah.
said that was the last exam, so I was confused. 'cause
Well-
You thought that was it? You thought that was
Yeah,
it?
no, sure.
Me too.
So we have our exam 4 on Tuesday. Our final exam is the Tuesday.
That's what I'm.
But there's no, final exam covers the whole course. This is the exam that covers what we just finished recently.
I was tripping. I
Yeah.
thought like she did.
No, you- you
I don't
haven't.
know why I thought that, but I just thought this is the last one.
Okay.
I'm still gonna see like you
Yes, there's, there are, that's a good question. Because exam 4 is week 14. We're not done. There are 2 more topics.
Are you kidding me?
So it's gonna be. So
He's like, no.
Control the brain mouth thing. Okay, because these are not good comments at this point. You just sound like you're whining now.
I'm not the only one.
We have 3.5 weeks of school left. We're only in week 13. It's a 16-week semester. After the exam, we will have 2 more topics, and then it'll all be review after that. There's a lot of, and the review is mostly so you have time to go back over things. It's less about what we physically do in here, as you're saying. If we had lecture and then the final was the next day, which by the way is 99.9% of all the classes you'll ever take the rest of your life, you have a lecture the day before the final. People don't review. At universities, there's no review. They lecture and then you have a final and you're like, how am I supposed to prepare? Oh, that's on you. No, I don't like doing that because then you don't have good results. We finish content We finished content on the 17th. Okay, and then it's review at that point. But we talked about this last week. When do you actually start reviewing in any class? I mean, literally after the first day of class, because once you have something, so in our case, the review really should have already started in terms of like going back over old things and retaking old tests and stuff. It does not matter what you knew in February if you don't remember it in May. So you could be perfect on the first test, but if you've forgotten it, you're not going to remember it when you sit down and take a final. That's why it's really important that you go back over, retake old exams. Does anybody here ever retake the quizzes? I think most of you do. Yeah, and does that help you prepare for the exam? Yeah, it makes things fresher and you're more focused because our exams have only been on generally 5 lectures. It's more, most of my classes I do more. You have one more exam than I do in most classes. So it's shorter bites of material, but it means we can't have huge gaps because if there's not a lot of material and I have a huge gap, there's a lot of things I won't be able to answer. So redoing things in mathematics is always a great way to prepare. It doesn't matter if you knew it a long time ago, if you've forgotten it now, you've got to make sure you remember it. And the nice thing is, if you missed it a while ago, you may have figured it out now. That's the other thing. Sometimes we miss something and then when we go back over, we go, oh, okay, I got that. And since this class is largely formula related, by using the right formula, I'm going to get it right. But then I have to also trust that I'm doing the calculator correctly. Yikes. and then tables. Yeah, that's it.
If you're dropping to one exam, does that only count for the first 4 exams or the final one?
Final can't be dropped on. Final.
Okay, that's what I
Yeah.
just wanted.
Yeah, the final's worth a little more. It's not worth a lot more. It's only worth a little more than the regular exams. But your top 3 exams are what you're gonna do. So if you've had an off year, and some people missed an exam, that's a dropped exam. It happens. You know,
Just don't miss.
it happens. Yeah, don't miss 2. Yeah, don't miss 2.
So after this exam, are you still, that process